I want to show you one somewhat more explicit example of doing debugging. And I want to do this to highlight this idea of treating debugging as a search problem. We've already talked about it, but basically I want to look for an explanation for the incorrect behavior. And I'm going to do that, as I said, by looking at the available data, both the correct cases and the incorrect ones, and trying to come up with a hypothesis about why I'm seeing that behavior, something consistent with the data. Then design and run a repeatable experiment that has the potential to refute the hypothesis. This is really just the scientific method. And keep track of that until I narrow down the range of hypotheses and I find where the bug, or bugs, because there may be more than one, actually exist. One of the ways to do this is to do it literally by search. And binary search is a really powerful tool for doing that. So what I'm going to do is give you a piece of buggy code. So when you see it, don't panic. I know there are bugs in there. I put them in there deliberately. And what I'm going to do is insert a set of print statements to help me narrow down, by bisection search, where are the bug or bugs that may be causing this kind of behavior. And that's going to give you a way of seeing both how print statements help as well as how search is going to help me find those bugs. So here's two functions. They're attempting to tell me whether something is a palindrome or not. Similar to what I did earlier, but here I'm going to actually have a little function, it's called silly, deliberately, that's going to take in a number, and I'm going to type in a set of characters, up to that number of characters. Use that to pull together a list, as you can see, because I'm going to build a list here in result. And then I'm going to run that through ispal, which is going to basically take the list, take a reverse version of the list, and then compare them. Because if they're the same, that's another way of testing if it's a palindrome or not. That's different than what we did before, but it's a nice way to test a palindrome. Whether this is the best way to do it or not, I don't care. What I want to do is use this as a debugging tool. So with that in mind, I've got a version of my buggy code over here. I'm going to load it into my machine. And I'm going to run silly a couple of times just to test it out. So I'm going to run silly, with 5. And I'm going to enter A, B, C, B, A. And it says it's a palindrome. That's good. It was. That's great. Let me do silly again with 10. And I'm going to enter P, A, L, I, N, N, I, L, A, P. And correctly it says it's a palindrome. Now if I'm in a hurry, I say, great, this works. But I've only tested it on things that actually are palindromes. So let's try it on something that isn't a palindrome, just to make sure that I haven't missed something here. So I'm going to do a really simple case, silly of 2, and I give it A and B, and it tells me it's a palindrome. Oh crap, I got a bug. Okay, now I want to get into debugging mode. So I need to try and figure out where is this error occurring. So I've run it as I said here. It worked on this case, it worked on this case, but it says that it was in fact a palindrome, which is wrong. So I'm going to pick a spot halfway through the code and simply look at the intermediate values. And so in particular, I'm going to insert a print statement right here, right at that spot. And that print statement is going to look at the value of result before I ever actually called ispal. I want to check to see, am I handing into the thing testing for palindromes something of the right form? So I have a version of the code like that over here, and I'm going to call it, and I'm going to run silly again, and I want to see what happens when I print out intermediate results, and I give it A and B, and I have a problem. What's the problem? Well, I would have expected at this point that I should have had the list of A and B. But when I ran the code, I just got B. Now, because of binary search, I know that at least one bug must be present earlier in the code. So I want to add a second print in, this time inside the loop, to see what's going on. And when I say inside the loop, I was looking after I'd gone through this loop, and I know that the error here says that I'm not getting the right kind of list. I'm going to do something inside the loop to see if I can figure out what's happening there. So let me now put a print statement inside the loop. And let's see what happens if we run it. So now I've got a new version of the code. I'm going to print out the result each time through as I do it. And I'm going to run that. I'm going to go over and call silly again. 2, and I give it A, and it prints out the list A, and I give it B, and it prints out the list B. Ah, that's telling me something valuable. It's telling me that each time through, I'm just putting into result just a single element. So append somehow is not doing what I expected it to do. And that suggests that the result is not keeping all of the elements. And in fact, I can probably already figure out what the problem is. The problem is that I'm initializing a result inside the loop, and I really want to initialize it outside the loop. If I go back to my code, right, you can see right here, every time through the loop, I'm setting result back to an empty list and then just putting the next element into it. I really want to set up result outside the list and then see if I can append. I use this as an example because you've probably made this mistake. It's an easy one to do. So let's now move result, as I said, from this position and put it at that position. And with that in mind, here's a version of that where I've moved that initialization. I've still got the print on the inside. Let's run it. And when I test silly, 2, and I give it A, it says I got the list A, and I give it B. Oh, good. I'm now at least getting the list in the right form. That's good. That's encouraging. It now tells me that the list is being delivered in the right form, but I'm still getting an incorrect answer. And that tells me that I still have another bug. So the data structure is being properly set up, but there's another bug, and that's really important. It would have been really easy to say, I'm done, but I'm not. There may be more than one problem. And this suggests that the second or maybe third bug must lie somewhere below the print statement. So let's go look at ISPAL. As before, let's pick a point in the middle of the code, add a print statement, and see what we can do in terms of trying to find it. And I'm going to remove that earlier print statement because I don't need it. So now up inside of ISPAL, I'm going to add a print statement. And I'll remind you, I need to decide what do I want to test. So here, what I'm trying to do, as you know, is take X, which should be a list of these of characters. I'm creating a temporary version of that, and I'm trying to reverse it. So I'd like to check at this point, is temp different from X? It should be a reverse version of that. All right, I have a version of that on my machine. Let's just load it and run it and see what happens. And as before, I'm going to do silly with 2, and I give it A, and I give it B. Oh, that's interesting. I was trying to reverse the list. And what was I testing here? I was saying, what is the structure of temp and what is the structure of X? I would have expected them to be reversed, one from the other, and they're not. So it should have been that X was AB and temp should have been BA, but they both have AB. So I've got a problem, and it must be happening before this point in the code, because when I get here, I have the incorrect structure. So let's add another print statement a little earlier in the code. And now I'll put a label on it so I can see where I am, because I got multiple print statements. So I'm going to now have the one I had before, which is after the reverse, and I'm going to have the one that I was going to do it before the reverse to see what's going on. Okay, with that in mind, I'm going to come over and try this. I've got now a piece of code with those two print statements. And when I run it, and I run my silly example, A and B, so it wasn't reversing. Even if temp started off as the list X, I printed it out, it was in the right form. After the reverse, it's not. So temp has the same value before and after the call to reverse. And if I look at the code, I can see the bug, and it's a standard one. I forgot to actually call the procedure. I just need an open and close paren. Okay, let's try that and see if that helps what we were trying to do. So now I've got a version of that, and I call it, and I run my silly example with 2, and I give it A, and I give it B. Some progress, but not quite what I wanted. Because now temp and X were the same beforehand, now both of them are reversed. Crap, what happened? I got a reversal, but I got both of them reversed. So putting that in led to having both of them reversed. And now we've simply narrowed it down to a single line. The error must be in that line where I did the call. And I can actually figure out what it is. The problem is we've got an aliasing bug. Reversing temp has caused X to also be reversed. And that's because they're referring to the same object. And I can see that in the code. What did I do? I said, let temp equal X. Oh yeah, that's pointing back to exactly the same structure as X. So when I reverse temp, I reverse X. I've got an aliasing problem. There's an easy fix. And that easy fix is to make a copy, to clone X before I do temp. And with that last change, hopefully I'm finally done. And if I do that, and I run it, and I run silly with 2, I give it A and I give it B. Finally. Now I can see that after the reverse, temp is reversed, X is not, and it says in this case it's not a palindrome. So it took me a while. I had multiple bugs, but I found them. And the message I want you to take out of this is that using that binary search really helped me isolate where those bugs were by thinking about what should I expect at this point, what do I actually see at this point, and what does it tell me about that hidden bug that I wasn't able to spot. So at this point, I should actually go back and check that all our other test cases still work properly. I'm not going to do that, but that is actually part of the good testing patterns, is to make sure that having fixed this set of bugs, I don't still have some hidden bug still showing up somewhere, or that I haven't accidentally introduced a new bug into some of those other test cases. So a last set of just pragmatic hits. Look for the usual suspects. What are the standard places where you might make an error? Aliasing being an obvious one. I found that by looking at when I reverse something, does it reverse everything or just the thing I was trying to reverse? Secondly, ask why the code is doing what it is, not why it's not doing what you want. The latter is because you've got a bug. Asking why the code is doing it is going to be helpful in helping you isolate where the bug might be. Third, the bug is probably not where you think it is, so try and eliminate locations. That's where the binary search, the bisection search, really helps. As we've already said, try and explain the problem to someone else, including a rubber ducky. Don't always believe the documentation. It may say, here's what I'm expecting, but it may not actually explain it. So if I'm still having a hard time finding the bug, ignore the documentation for a second and try and isolate in. And finally, if you've been at it for a while and you're not getting there, take a break and come back later. A fresh look can often help you suddenly spot a problem that you weren't seeing because you had hidden assumptions about what you were looking for.